All right, so we start by reading the description. A tower casts a shadow 55 meters along the side of a hill. An observer at the furthest edge of the shadow, right? I added in the word shadow, measures the angle of elevation to the tip of the tower, adding in words, to be 35 degrees. If the slope of the hill is 15 degrees, how high is the tower? Okay, so let's start off with some level ground. Here's level ground. And the slope of the hill, it's a bit higher than 15 degrees, but it's too hard to label things if it isn't. There we go. And we need a tower on the hill. All right. Now, the sun is shining. We'll assume the observer doesn't have any height, just to keep it simple. And let's see, before we do that, let's put the shadow, and I'll make the shadow stand out somehow. Let's see, we'll make the shadow red, maybe. Here's the shadow, right? And the observer's at the base of the hill, there, close to the base, and we'll assume they have no height, and, there we go. There's the view to the top. And of course, because of the person's position at the edge of the shadow and having zero height, means the sun is here, right? The sun is here. So let's just finish labeling some things. We have a shadow of 55 meters. We have the hill's elevation at an angle of 15 degrees. More work, the angle of elevation. Here, I'm just drawing a little horizontal line. That is 35 degrees. Label it out here. So the actual angle inside of there is 35 minus 15, or 20 degrees. And that's this part right in here. Okay. I see the formation of a triangle. And I'm going to sketch it off to the side. Maybe that'll make it a little easier to see. What I have is 55 meters and 20 degrees. Now, that's only two pieces of information. I can't solve this triangle with only two pieces of information. I need another, what am I looking for? The height. Okay. So I still need one piece of information. So I need to go back to the original diagram and think about it. And there's more stuff to be had, of course. We go down the center of the tower, makes a 90 right there, right? This is 15. Oh, has that up to 180, so this has to be 75. Supplementary angle, so that has to be 105, so that's 105. Okay, so that triangle is solvable now. So let's just go through and do that. The height over the sine of 20, right? There's the item I don't know with a ratio with its sine of the angle across. Oh, I still need more. This 180 minus 20 minus 105, 55 degrees. Angle sum of a triangle theorem. So we have 55 over the sine of 55 degrees. And h is equal to 5 sine 20. 55 sine of 20 over the sine of 55. And we have 22.96 meters. That's what I have written down. Hopefully that's right. Now, that's not the only case. Who says the sun has to be shining, the shadow going straight down the hill? Maybe the shadow is going straight up the hill. This is 55. And our observer then is standing uphill of the tower and is like this, and maybe the sun is directly downhill from the observer in the tower like this. What will that give us? Well, it's still a triangle, obviously. Let's see what we know. here's the height we want this time. We have 55 meters still here. Well, the tower is considered to be vertical. The angle of the sun is still the same. So we're still going to have this 55 degrees. So, that proportion of 55 degrees opposite 55 meters is still there. Does that mean the whole thing's the same? Well, not really. If we look at this a little more carefully, right in here, we have the angle of observation of 35 degrees. And this will be the 15 degrees for the hill. Well, that adds up to 50 degrees. So this is 50. And of course, we don't even need that. So h over the sine of 50 is 55 meters over the sine of 55. So h times 55 sine of 50, this time instead of the 20, over the sine of 55 degrees. And h will be 51.4 meters. So is that the only option? Well, no, the sun doesn't have to be shining straight down or straight up the hill. The observer exactly opposite. We're not told anything about that. Well, what if it's shining so it's along the perpendicular to the direction of the slope or some other angle? Well, these are the extremes. This is the tallest or the shortest we would estimate the tower to be. So I guess all we can really say, given this question, is that the tower is, between those two heights. And I guess that's it.